Alright, so today we are going to be looking at sectioning method. So we are going to be using sectioning method to solve some problem under shear force and bending moment as demanded by some of my students here. Alright, so the first question says that we should prove that the maximum bending moment for a simple supported beam with a concentrated load at a mid span is PL all over what? 4. The first thing we are going to do is for us to draw a simple supported beam that carried load of what? P. Some textbook will use W, so just take note of that. Alright, so you can also have this formula to be WL over 4. Alright, so now for us to solve this question, the first thing we are going to do, we are going to start with the summation of our what? Upward forces. Alright, so summation of upward forces equals to what? 0. Then we are going to take our coordinate. Upward force positive, downward force should be negative. Alright, so and we know that the two upward forces here is the reaction at A and the reaction at B. So let's take this beam to be A, this place to be B, point B. Alright, so here we are going to have reaction at A plus reaction at B to be equals to P. So we can call this one equation number 1. Alright. So the next thing we are going to do is we are going to take the summation of moment about point what? Point A. So we are going to say the summation of moment about point A should be equals to 0. Alright, don't forget, we've already said upward force should be positive, downward force should be negative. So it means that the moment created by our upward force will also be positive, and the moment created by our downward force will be what? Negative. And you can see our upward force is going to create an anti-clockwise moment, while our downward force is going to create a what? A clockwise moment. And moment is nothing but what? The product of force multiplied by what? The perpendicular distance. What do we mean by perpendicular? It means it must incline at 90 degree. 90 degree. So here we are taking our moment about point A. So here is our force here. The perpendicular distance is the point is from this point to this point. So it's going to be arrow B multiplied by what? By L. So we are going to have a reaction at B multiplied by L. Alright. So again, here we are having a downward force here, which is going to be what? Negative, multiplied by the perpendicular distance. Don't forget, this load is acting at the what? The mid span. So it means that from this point to this point is going to be what? L over 2. From this point to this point is going to be what? L over 2. So it means that this is going to be P multiplied by what? L over 2. So now it's going to be minus P multiplied by L over 2. So everything will be equals to 0 because we don't have any other force there. Alright, so from here we can therefore say our reaction at B L will be equals to, because RB multiplied by L is RBL, will be equals to PL over 2. PL over 2. So here, you know that this L will go with this L. So we are going to say our reaction at B will be equals to P all over what? 2. Alright, so can we get our reaction at A? Yes, of course. If we make our reaction at A the subject of formula from equation 1, reaction at A will be equals to P minus reaction at B. So this will be equals to P minus P all over what? 2. Alright, so if you take your LCM, it's going to be 2 multiplied by P, that is 2P. 2P minus P is P. So the LCM of 1 and 2 is 2. So it's going to be P over 2. So here we are going to have our reaction at A to be equals to P all over 2. So it means if you have a simple supported beam with a load at the mid span, they are going to share the load equally. They are going to share the load equally. That is, they are going to have same load. So here we have our reaction at A and then reaction at B. So here we are going to apply our sectioning method now. Alright, now this sectioning method will be understood as much as you keep watching our video on this, because you cannot grab all the concepts for now, because this is just the first question. All right, so you have to stay tuned. By the time we solve the first, second, third, fifth, sixth, and the 10th question, you might have understood the concept of sectioning to solve question on shear force and bending moment. Now, this is a simple supported beam. You can see from this point to this point, we only have a point load. From this point to this point, we don't have any load. But for us to, admin, we are solving this question completely. Admin, this question says we should sketch the shear force diagram and the bend moment diagram. We are going to be sectioning this beam in two places for us to solve the for us to be able to do that. But since the question is just telling us to show that the maximum bending moment is PL all over 4, so we only need to section this beam in one point. And what I mean is this: anytime you see any beam and you want to apply sectioning method, the first thing you are going to do is check from this point to this point we have a load, right? From this point to this point. Now, the meaning of this is for us to solve this beam completely, for us to solve this question completely, to be able to solve shear force, to be able to draw shear force diagram and bending moment diagram, the first sectioning will be between this point and this point, and the second sectioning will be between this point and this point. So, but there's no need for us to do that, because we just want to prove that the maximum bending moment is PL over 4. I hope that point is understood. So for us to do this, we are just going to be sectioning the moment in this point. So let's section the moment here. All right, so let's call this point S. So it's going to be at a distance of S. All right, so it's going to be at a distance S. All right, so now we are going to draw this part out from this point to this point. We are going to draw it here, and we are going to analyze it. All right. All right. All right, I'll just make it big here, and you can see it clearly. All right. All right, please always make your work to be very neat. All right, so here we are having a reaction at this point. All right, so which is reaction A, and from this point to this point is X, and here we are going to have section SS. All right, so you are going to take note of something here clearly. Anytime you section a beam and you want to draw out the beam, we are going to have moment, we are going to have shear force, and then we are going to have normal force. But since we don't have any horizontal force here, we are not going to consider the normal force. This is it. We are going to have moment. The moment is going to be, so we are going to call this M subscript S, and here we are going to have a downward shear force. All right, so we are going to have a shear force which is going to be denoted with V. All right, so this is what we are going to have. So we are going to have a normal force as well, but since we don't have any horizontal force here, so we are not going to consider that. So this is what we are going to do now. So now the next thing, we are going to be considering this sectioning part. So you can write considering section SS of the beam. All right, so first thing we are going to do is to take our moment about point A. So we have here to be A, and then we have this. Okay, so we are going to be taking our moment So if we take our moment towards this part rather, so we are going to have moment, sum of moment about the sectioning part to be equals to 0 rather. All right, so we are going to have, don't forget, our conditions still remain the same. Upward force is positive, downward force is negative, and the moment created by these two assumptions remain the same. All right, so here this is, if we take our moment towards this side, this is our force. The perpendicular distance is s, so it's going to be RA multiplied by what? S. But our upward force is what? Positive. So here we are going to have RA multiplied by S. RA multiplied by S. All right, that is the only force we have there. But don't forget, we also have another what? Moment here, which is going in this manner, right? It's going in an anti-clockwise manner, right? So here, this moment here is going like this, right? And we said it should be what? Positive. So this upward force here is creating a clockwise moment here. So it means for this case here, clockwise moment will be what? Positive. Take note of that. While this moment here, which is going in this direction, will be what? Negative for this case. All right. So here we are going to have minus what? Minus ms here. That is the moment at the section now. So it's going to be, everything now will be equals to what? 0. All right. So now if I make my ms the subject, if I move it here, I'm going to have arrow subscript a s to be equals to m subscript s. So it means that I can say that my m subscript s will be equals to arrow subscript a then s. But don't forget, my reaction at a is what? P over 2. So I'm going to have the bending moment at section s to be equals to P s all over what? All over 2. So that's it. All right. So now, how do we get the maximum bending moment? All right. Now, if we draw, if we draw the bending moment, but we don't even need to draw. Let's just sketch it. Now, if we, as this as this load is acting at the midspan of this beam, the beam is going to bend in this manner. All right, so you can see that it's going to bend in this manner. So we are going to, at this point, our s is going to be equals to what? 0, and at this point our s is also going to be equals to what? 0. So but at this point here, we are going to have our maximum bending moment at the midspan of the beam, at the midspan of this beam, and we have said at this point to this point is what? L over 2. So it means that at a distance of s equals to what? L over 2, we are going to have our maximum bending moment. So it means that at s equals to L over 2, at s equals to L over 2, we are going to have maximum bending moment. So we are going to say M max will be equals to P all over 2 multiplied by s, which is what? L over 2 now. So here we are going to have this to be equals to PL all over what? All over 4. So which is going to give us maximum bending moment. So this is how to prove, this is how to solve the above question. I believe we understand. So stay tuned for more questions so as to grab the concept of what? Section method. Thanks.